Hello students, I hope you all are doing fine out there. So we are doing proof trigonometrical identities, isn't it? So today we'll start exercise 21E, okay? Exercise 21E, right from question number 1, prove the following identities. So I have already copied question number 1 of 1. So let's begin from this question. So we have 1 upon cos A plus sin A plus 1 upon cos A minus sin A in the left hand side, and we are asked to prove this equals to 2 cos A upon 2 cos A square A minus 1, isn't it? So LHS equals to 1 upon cos A plus sin A plus 1 upon cos A minus sin A. Now let's take the LCM of the denominators. If the numbers are like this, if there is no common multiplication table between the two numbers, what we do is we just multiply them and write the LCM as 6. 2 into 3 is 6. Now 2 3s are 6, 3 1s are 3 plus 3 2s are 6, isn't it? So 2 1s are 2. The same thing we are going to do here. We are going to take the LCM of the denominators. So there is no common multiplication table between these two numbers. So the LCM will be cos A plus sin A into cos A minus sin A. Okay. So now cos A plus sin A into cos A minus sin A gives this whole thing. That means cos A minus sin A 1s are cos A minus sin A plus comes here. Now cos A minus sin A into cos A plus sin A gives us this whole thing. So cos A plus sin A into 1 cos A plus sin A, isn't it? Now we have minus sin A plus sin A can be cancelled. So cos A plus cos A, 2 cos A. This is what we have in the numerator. So in the denominator we have A plus B into A minus B, okay? We assume this cos A as A and sin A as B. A plus B into A minus B means we know the formula. A plus B, A minus B means A square minus B square. So this is cos A square A square minus B square, isn't it? Minus B square is sin square A plus B, A minus B, A square minus B square. So 2 cos A is in the numerator, 2 cos A. In the denominator we need cos square A, isn't it? So let's convert this sin square A to cos square form. So cos square A we copy as it is, cos square A minus here. Now sin square A means, since we know that sin square A plus cos square A equals to 1, isn't it? So sin square A equals to 1 is already in the right hand side, plus cos square A if you take to the right hand side becomes minus cos square A. So you can write, instead of sin square A, 1 minus cos square A. So this sin square A can be written as 1 minus cos square A. So we have 2 cos A in the numerator, 2 cos A in the denominator, cos square A minus into plus, there is plus sign in front of 1, okay, minus into plus, minus 1, minus into minus, plus cos square A. So let me continue here. 2 cos A is in the numerator, 2 cos A. In the denominator we have cos square A, cos square A. This cos square A is also plus and this cos square A is also plus. So plus cos square A plus cos square A, 2 cos square A, isn't it? So minus 1, minus 1. So this is what we have in the right hand side, isn't it? So this is RHS. Hence proved. I hope you got this. Now let's do question number 2 of 1, okay? Okay, now let us do question number 2 of 1, okay? We have cosec A minus cot A in the left hand side, and we are asked to prove this equals to sin A upon 1 plus cos A, isn't it? So let's do this. Left hand side equals to cosec A minus cot A. So we are going to use this and prove this. So cosec A and sin A are the reciprocal of each other, isn't it? So cosec A can be written as 1 upon Sin A minus comes here. Cot A can be written as cos A upon sin A. Cot A is written as cos A upon sin A. Okay. So let's take the LCM of the denominator. Sin A, sin A. LCM will be sin A. So sin A into 1 is this sin A. That 1 into this one is 1 minus this sin A into 1 is sin A. That 1 into cos A is cos A. So we have 1 minus cos A upon sin A. But we need sin A upon 1 plus cos A. So let's multiply by 1 plus cos A in the numerator and in the denominator. 1 plus cos A. Okay. So 1 minus cos A into 1 plus cos A. That is A minus B into A plus B, isn't it? So A square minus B square. So A square means 1 square, 1 square means 1, isn't it? 1 square means 1, 1 1s are 1. So A minus B into A plus B is A square minus B square. That is 1 square is 1 minus B square is cos square A. In the denominator we have sin A into 1 plus cos A. This sin A into 1 plus cos A. Sin A into 1 plus cos A. So 1 minus cos square A is, since sin square A plus cos square A equals to 1. So sin square A equals to 1 minus cos square A, isn't it? So plus cos square A, when we take to the right hand side, becomes minus cos square A. So 1 minus cos square A means, 1 minus cos square A means sin square A. So this whole thing is sin square A. Sin square A. In the denominator we have sin A into 1 plus cos A. Let me write clearly, okay? 1 plus cos A. So here we have sin A and sin A. Sin A into sin A. This gives us sin square A. And here we have 1 sin A. So 1 sin A and 1 sin A can be cancelled. So in the numerator we have 1 sin A. Sin A. And in the denominator we have 1 plus cos A, because the sin A is cancelled, isn't it? So 1 plus cos A. So this is what we have in the right hand side, isn't it? Equals to RHS. Hence proved. Now let's do question number 3. Okay, now let us do question number 3 of 1. Okay, we have 1 minus sin square A upon 1 plus cos A in the left hand side, and we are asked to prove this equals to cos A. So let's do LHS equals to 1 minus sin square A upon 1 plus cos A, isn't it? This is what we have in the left hand side. So let's take the LCM. Here we have 1 in the denominator of 1. 1 and 1 plus cos A. The LCM will be 1 plus cos A. So 1 plus cos A into 1. 1 plus cos A. Because 1 into 1 plus cos A gives us this whole thing, 1 plus cos A. So 1 plus cos A into 1 is 1 plus cos A. This minus sign comes here. 1 plus cos A into 1 gives us this thing. So this 1 into sin square A is sin square A. So here we have 1 plus cos A, we copy as it is, minus this sin square A can be written as 1 minus cos square A, isn't it? Sin square A means 1 minus cos square A. So in the denominator we have 1 plus cos A. Cos A. So this 1 plus cos A, this 1 plus cos A we copy as it is. Now minus into plus is minus 1, minus into minus is plus cos square A. In the denominator we have 1 plus cos A. 1 plus cos A. Now let me continue here. So this plus 1 and this minus 1 can be cancelled. We have cos A and cos square A, isn't it? So let's take the common cos A out. Cos A is taken common. So cos A is taken common means here we have 1, isn't it? Plus, so here we have 2 cos A, so 1 cos A remains within the bracket. Are you getting me? Cos A into 1 gives us cos A. Plus into plus, plus cos A into cos A is cos square A. From this cos A and cos square A, I take cos A common. So within the bracket remains 1 plus cos A. In the denominator we have 1 plus cos A. 1 plus cos A. So this 1 plus cos A from the denominator and from the numerator 1 plus cos A can be cancelled. So remains cos A. So this is what we have in the right hand side, RHS. Hence proved. Now let us do question number 4. Let's do question number 4 of 1. Okay, we are asked to prove 1 minus cos A upon sin A plus sin A upon 1 minus cos A is equals to 2 cosec A. So let's take the first, let us copy left hand side. LHS equals to 1 minus cos A upon sin A plus sin A upon 1 minus cos A, isn't it? So let's take the LCM of the denominators. Sin A into 1 minus cos A. LCM will be sin A into 1 minus cos A, isn't it? Sin A into 1 minus cos A will be the LCM. So sin A into this gives us whole thing. So 1 minus cos A into 1 minus cos A, 1 minus cos A whole square. Same number multiplied 2 times, isn't it? 1 minus cos A into 1 minus cos A, 1 minus cos A whole square. Plus 1 minus cos A into sin A gives this whole thing. So sin A into sin A gives us sin square A. Now here we have A minus B whole square, isn't it? Let us consider this one as A, cos A as B. A minus B whole square means A square, that is 1 square is 1, minus 2AB, 2AB. Okay, let me write this. 2AB, 2 into 1 is 2, B is cos A. So 2 cos A, isn't it? 2 cos A, 2 cos A, 2AB plus B square means cos A square A, plus comes here. Now this is sin square A. Are you getting me? A minus B whole square means A square minus A square is 1 square, 1 square is 1, minus 2AB. 2 into A is 1, 2 1s are 2, B is cos A. 2AB plus B square means cos square A. This plus comes here and this is sin square A. Okay. So now we have in the denominator sin A into 1 minus cos A, sin A into 1 minus cos A. Now this cos square A plus sin square A means 1, isn't it? So 1 minus 2 cos A plus 1 minus 2 cos A, 1 minus 2 cos A plus cos square A plus sin square A is 1. In the denominator we have sin A into 1 minus cos A. So this plus 1 and plus 1 is plus 2, isn't it? Plus 1 plus 1 plus 2 minus 2 cos A, 2 cos A. Are you getting me? This plus 1 and this plus 1 is plus 2 minus 2 cos A minus 2 cos A. In the denominator we have sin A into 1 minus cos A. Sin A into 1 minus cos A. Now let us take the 2 common out. 2, 1 minus this 2 is taken out, so 1 remains within the bracket, minus this 2 is taken out, so cos A remains within the bracket. In the denominator we have sin A into 1 minus cos A. So this 1 minus cos A and 1 minus cos A can be cancelled. So we have 2 upon sin A, isn't it? 2 upon sin A. This sin A, if you take to the numerator, becomes cosec A, because cosec and sine are the reciprocal of each other. So this sin A in the denominator, if you take to the numerator, becomes cosec A. So this is what we have in the right hand side, isn't it? So RHS, hence proved. Now let us do question number 5. Okay, let us do question number 5. So we are asked to prove cot A upon 1 minus tan A plus tan A upon 1 minus cot A equals to 1 plus tan A into cot A. Sorry, 1 plus tan A plus cot A, isn't it? So let's use this left hand side and prove this. Okay, LHS equals to, we have cot A upon 1 minus tan A plus tan A upon 1 minus cot A. So let's convert this into cos and sine form. Okay, cot A means cos A by sine A, cos A by sine A, isn't it? So whole upon 1 minus tan A means sine A by cos A, sine A by cos A. So this plus comes here. This tan A means sine A by cos A, whole upon 1 minus cot A means cos A by sine A. Okay, so this numerator we copy as it is, cos A by sine A. In the denominator we take the LCM. Okay, so we have 1 in the denominator of this one. The LCM of 1 and cos A is cos A, isn't it? So 1 into cos A gives us this cos A. So cos A into 1, cos A, minus cos A into 1 gives us cos A. This 1 into sine is sine A, plus this is sine A upon cos A. We copy as it is, sine A upon cos A. In the denominator we have 1, so the LCM of 1 and sine A is sine A. So 1 into sine A gives us this sine A. Sine A into 1 is sine A, minus 1 into sine A gives us this sine A. So 1 into cos A is cos A, isn't it? Sine A into 1 gives us this sine A. So 1 into cos A is cos A. Okay. Now we have cos A upon sine A. This cos A upon sine A. If I change this whole upon into sine, the number from the denominator goes to the numerator. Cos A goes to the numerator, cos A, and this number cos A minus sine A comes down to the denominator. Cos A minus sine A comes down to the denominator, isn't it? So here we have plus sine A by cos A, sine A by cos A. We do the similar thing here also. This sine A goes to the numerator, sine A upon this sine A minus cos A comes down to the denominator, sine A minus cos A. Okay, I hope you are getting me. Now let me continue this sum here. So cos A into cos A is cos square A, cos square A, and in the denominator we have sine A minus sine A into cos A minus sine A, sine A into cos A minus sine A, cos A minus sine A, isn't it? Sine A into cos A minus sine A. Now this sine A into sine A, sine square A, okay, sine A into sine A, sine square A. Now from here we have sine A minus cos A. Let's take this minus sign common. Okay, so we can make cos A minus sine A similar to this number. We have sine A minus cos A here, and here we have cos A minus sine A, isn't it? If I take the minus sign common from this minus cos A becomes plus cos A, and this plus sine A becomes minus sine A. So it becomes cos A minus sine A, which is similar to this, isn't it? So let's take minus sign common from here. Okay, if I take minus sign common from here and multiply with this plus sign, this plus becomes minus, isn't it? So this is cos A into, now sine A minus cos A becomes cos A minus sine A, okay. Now cos A minus sine A, cos A minus sine A, LCM will be cos A minus sine A, isn't it? And sine A into cos A, sine A into cos A. So cos A into cos square A, cos cube A, minus this minus comes here, sine A into sine square A, sine cube A, isn't it? Because this whole thing into cos A, this whole thing into cos A gives this. So cos A into cos square A is cos cube A. This whole thing into sin A gives all this. So this sin A into sin square sin cube A. Okay, excuse me. So this is cos cube A minus sin cube A, means A cube minus B cube. What is the formula for A cube minus B cube? A cube minus B cube equals to A minus B A square plus AB plus B square, isn't it? The formula for A cube minus B cube. So A cube minus B cube means A is A minus B into A square plus AB plus B square. Okay, A minus B into A square plus AB plus B square whole upon sin A cos A, sin A, this is sin A cos A into cos A minus sin A, cos A minus sin A. So this cos A minus sin A and cos A minus sin A can be cancelled. So this means cos square A upon sin A cos A, sin A cos A plus cos A sin A upon cos A sin A upon sin A cos A, isn't it? So this plus sin square A upon sin A cos A, sin A cos A, sin A cos A, sin A cos A, sin A cos A. If we take the LCM, it becomes like this, sin A cos A, and the whole thing goes to the numerator, isn't it? So here we have cos A and here we have cos A square A. So one cos A and one cos A can be cancelled. So this can be cancelled. Here we have 1. So here we have sin square A and here we have sin A. Sin A can be cancelled. So cos A upon sin A. Here we have cos A in the numerator. Cos A upon sin A is cot A, isn't it? Plus this is 1 plus sin A upon this cos A. Sin A upon cos A is tan A, isn't it? So this is right hand side, 1 plus tan A plus cot A. Cot A plus 1 plus tan A means you can write this 1 plus this tan A plus cot A, isn't it? This equals to RHS. Hence proved. I hope you got this. Thank you so much. Stay connected. I'll be uploading more of the videos like this. Okay, in the next class I'll upload from question number 6 onward. Thank you.